Hello and welcome to STEM Pursuits with Mr. Clausen. Today I want to talk with you about properties of logarithms, and specifically what I'm going to do is I'm going to go over a battery of examples here talking about the properties of logarithms, specifically the quotient, power, and product properties. I want to talk about these real briefly, summarize the properties of logarithms, and then tie it into a real-world application that we're going to talk about in this video. So without further ado, I'm going to get started here. Specifically, what I want to do is that as I'm going through each of these properties, we'll go over an example, and then I'll show you a second example as we're going through. And the first one that I want to talk about here is the quotient property. And the quotient property allows you to look at two logarithmic functions with the same base, and it allows you to combine them under one logarithm in fraction form. So for example, if log base 3 of 32 is log base b of m, and log base 3 of 8 is log base b of n, then what we can do is we can keep the log base 3 portion of our logarithmic function, and in order to simply use the quotient property, we can go 32 over 8 and just simply put the subtracted portion in the denominator of this fraction, and then we would be applying the quotient property to this logarithm. And then what's useful about this is that if we can take an expanded logarithm and simplify it to a single logarithm, sometimes you can go and simplify the product of that, or quotient in this specific situation, of the logarithm. So 32 over 8 would be equal to 4, so we could say log base 3 of 4 would be a simplified version of log base 3 of 32 minus log base 3 of 8. And so the reason that we go over these is so that you can take more complicated logarithms that are separated and combine them into a single expression. And maybe sometimes it's useful to separate it back out. Maybe you have two separate variables here and you need to separate a variable. Sometimes it's useful to expand it as well. So if we look at something like log base 5 of r over s, okay, we can see this is log base b of m over n. If we treat s as the n, if we treat r as the m, and 5 as the b value here, then what we can do is just simply, using the quotient property of logarithms format here, separate this back out and go log base 5 of r minus log base 5 of s. And I always know it will be in this format because s is in the denominator. Whatever's in the denominator is going to have the negative sign here. And then this would be the expanded form of this expression. So if you want to expand a logarithm, that's what I just did here. And if you take something more complicated and you combine it together, we would refer to this as simplification. And then that is simply how you can use the quotient property of logarithms. So let's talk about the power property of logarithms, because this can be a really useful technique for simplifying logarithms. So in this specific case, you take a power associated with a given component, and whatever that power is, you can always pull that out front. And what you'll see is that if you have log base b of m to the x power, the x can always come out in front. I think of it as loading the trebuchet and shooting it over the log, and then you have this new value out in front in log base b of m. So what we want to do, just like we did in the previous video series, is that if you can take these radical expressions and put a rational exponent to them, the rational exponent can be pulled out front. Because remember, logarithms are these inverse power type functions. So what it allows you to do is it allows you to ask this question in more of a format as, how many times does m go into b? Well, if m goes into b 2 times and it's to the third power, well, you're just going to multiply it 3 times. So that's kind of how the power property works. So if I look at this logarithm here, I'm going to take this radical, and in this given situation, this is just log base 10 since nothing's identified. And the first thing I'm going to do is I'm going to rewrite this so that the power is in the form of a rational expression. So remember, a cube root, m over n, is just, if it's a cube root, it's going to be 1/3. If it's a square root, it's 1/2. Okay, and so if we have this logarithm here with this radical expression inside, we can rewrite it with the rational exponent, or if you understand how the radical component equals a rational exponent, you can just always do that. But if we write it like this, if it's the format that I have here, b is equal to 10 in this given instance, so it's just left blank. I load up the trebuchet, I shoot it out front, and then what we'll have is that we'll have 1/3 log base 10, so it's left blank, of 3x. And that's all you would need to do in this particular situation in order to analyze the problem. And this is just a simplification, so to speak. I mean, I'm not even sure if you would call it that. It'd almost be more of an expansion in this case. It is an expansion now that I'm thinking about it. And so, because we are taking something that is simplified and we're pulling it out front. But there could be some really practical reasons why we would want to do this. And if you have something like this problem down here where we have 2 log base 8 of 4 minus 1/3 log base 8 of 8, what we see here is something that is maybe a little dense to look at here. And one of the things I would do in this particular situation, if I wanted to simplify this into one logarithmic component, what I would do here is I would actually use the power property, but only in reverse. So if there's a component out here, I would reload the trebuchet by putting the 2 up here and take the 1/3 here, reload the trebuchet and put the 1/3 up here. And what this allows me to do is if I go and rewrite this, I can say log base 8 of 4 to the 2nd power minus log base 8 of 8 to the 1/3 power. And then I could actually use the quotient property, the property I just talked about previously, to take these and put one over the other. So this would be log base 8 of 4 squared over 8 to the 1/3 power. And actually, if we wanted to simplify this out, this would be log base 8 of 16 over 2, because the cube root of 8 is 2. And actually, if we do the cube root of 8, what we'll have there is that we will have log base 8, 16 over 2 is 8, and 8 goes into 8 one time, so the answer for this entire expression would just be 1. So instead of looking at these two components separately and trying to figure out how to chug your way through it, you can simplify it into one expression and see if it comes out to something really nice like this. Or maybe you want to expand it and then expand it into parts that are really easy to digest and then have one small part. There's certain ways that you can go about it depending on how you want to manipulate it. But really all I'm looking for right now is just, hey, can you use the quotient and power properties of logarithms to simplify or expand an expression? So the third skill I want to look at here is the product property. And what's really nice about the product property is if you have 2 logarithms with the same base, we'll see that there is no basis here. So this means base 10 in terms of this given expression, and that's fine. Base 10 is going to be the most common type of base you're going to use. Sometimes you'll use log base 2, sometimes you'll use log base e in real life. But there is that flexibility with logarithms. And so if we look at this given situation, if 2 logarithms have the same base, right, and they are added together, what we can do is go log base b of m plus log base b of n and combine m and n together under the same expression. So if we say w is squared is equal to m and z to the 4th is equal to n, then what this would allow us to do is rewrite this expression as log w squared z to the 4th. And you would be able to combine both of the components of the logs here under one log. So if we're looking at this, you know, we can expand it and go about the other way, which is what I'm going to do down here. So if we have something like log base 10 again of v to the 3rd power all over n to the 4th power and p to the negative 2nd power, I want to show you how this is simplification. And now we are going to expand this specific function. All right, and one thing I'm going to point out is that there is a denominator here. If I have a denominator, I'm going to use the quotient property first. All right, and the reason I'm going to do that is going to become very clear here at first. So I'm going to have log 2v to the third power minus log of n to the fourth and p to the negative second. All right, and so now that I'm looking at this, I have another pair of components here that are in a numerator, and I can apply the product property specifically to this component. So I could split this apart and go log to n to the fourth plus log to p to the negative second. And I could split this part even further, but keep in mind that this minus sign is in front of this, so the minus sign would get distributed. All right, and so this could equal something like log v to the third minus log base 10 n to the fourth minus log p to the negative second. And if I wanted to expand this even further, I could say, oh, let's use the power property, since the trebuchets are already loaded here, and pull all these powers to the front of the logs. And then we would get something like 3 log base 10 of v minus 4 log base 10 of n. Now we have a negative times negative 2, so we would have plus 2 log base 10 of p. All right, so hopefully you can see really quickly here that just with these 3 main properties of logarithms, you can expand and simplify until your heart's content with these logarithms. And to just briefly summarize, here's your quotient property, your power property, and your product property. If you're allowed to use a note card on your quizzes or your exams, I would write these down, I would identify them, because they're going to be really useful. And what you can do with a given situation like this, and what can be of practical use, is we can look at something like this and we can simplify and solve a logarithmic expression. Because I'm going to use the quotient and the product property, I'm not going to pull the powers out right away. So one thing I can do here is I can go log base 8 over 6 squared. All right, and what that'll equal for me here is, let's simplify this out just a little bit, log base 8 over 36. All right, plus log base 3. And then what I can do is I can use the product property and I can combine these. All right, and so I can go log base 3 times 8 over 36. All right, so here I use the quotient property to combine these two here. And then I use the power property, the product property, to combine these two here to get this final component of log of 24 over 36. And what this will allow you to do is you can simplify this to log of 2 over 3. And what I'll tell you is that if you try to do all these separately, yeah, you could get the same answer if you're plugging it all into your calculator. But if you have a perfect whole number, sometimes you'll have some rounding errors. So generally what I like to do is simplify it into one logarithm, plug it into a calculator, and then you'll find for a given example like this that you'll have a value of negative 0.176, and you'll know that it's negative because you have a number less than 1. And then you can simplify a given logarithm as such. All right, and then you can expand or anything else with those. So you can kind of see how you can use all 3 properties of logarithms in one problem and use it to solve or evaluate a given scenario. So with that said, I'm going to stop the video here because we have about 16 minutes of content, and create a second video discussing how to use the properties of logarithms and apply them to real-world applications. So with that said, let's do some math.